We're moving on to solving exponential and logarithmic equations. So we know a little bit about logarithmic equations, exponential equations, and we know that they are inverses of each other, which is something that we can use to help us solve equations. So if b to the power of m equals b to the power of n, then that would mean that m and n have to be equal. So if this was like we had 3 to the x equals 3 to the fifth, well, that implies that x would also have to be 5. So we can rewrite the equation in the form bm is equal to bn, and then set m and n equal to each other, and then solve for any variables that we might have. So if we have 5 to the power of 3x minus 6 equals 125, from here, I can't do anything because what I require is that I have the same base. But what I can do is that 125 is just 5 to the power of 3. So we just take 125 and write it as 5 to the power of 3. Now we have two base 5s, so now we can say that 3x minus 6 is equal to 3. And then if we solve this, 3x is going to be equal to 9, x is equal to 3. We now have a solution. And we can double check it. So 5 to the 3 times 3 minus 6 is going to equal 5 to 9 minus 6, which is going to be 5 to the third, which is going to be 125. Here we have 8 to the power of x plus 2 and 4 to the power of x minus 3. Once again, we do not have the same base. But we do know that 8 is just 2 to the power of 3. And we know 4 is just 2 to the power of 2. So we have a rule that says if I have a to the m raised to the n, then I could just take it and have a to the m times n. So I have 2 to the power of 3 raised to the power of x plus 3. That means I just have 2 to the power of 3 times x plus 3. Here I have 2 raised to the power of 2 times x minus 3. So now that we have the same bases, we know that 3 times x plus 3 is equal to 2 times x minus 3. And now we just have a linear equation to solve. 3x plus 9 equals 2x minus 6. So we get x is equal to negative 15. So just realized that there was a little error there. That was x plus 2. So let me just go back here, fix that. So that's x plus 2, x plus 2. So then we have 3x plus 6. So it will be equal to negative 12. Now, if we want to use logarithms to help us solve an exponential equation, we'd like to isolate the exponential expression to it by itself. So our b to the x, or whatever it is, should be by itself. We're going to take the common log of both sides of the equation for base 10, and then we take a natural log to both sides of the equation for any bases other than 10. Simplify using one of the following properties, which is natural log of b to the x equals, sorry, let me recircle that. Natural log b to the x equals x log b, or natural log of e to the x equals x. So remember, we had this rule that said a log base b of, I think we said m to the n, of m to the n, it could be written as n log base b of m. So that's all this part is doing, is saying that we're just trying to get this x out. So we're using this property that we learned about the powers and logarithms to help us get our x out of the exponent. Or we might have a situation where we have a log base 10x, log base 10 of 10x is going to give us x, and we're going to solve for the variable. So here we have 5 to x equals 134. So it's not a base e, and it's not a base 10. So what we do is we just default to natural log. So natural log of 5x is going to be equal to natural log of 134. Now, what this means is I can drag this x out. So x is equal to natural log, sorry, let's try that again. We have x, natural log of 5 is equal to natural log of 134, meaning x is just the natural log of 134 divided by the natural log of 5. And we cannot combine these, we have to leave them as is. So in this case, we'll have to put the answer in a calculator. So if you do natural log of 134 and divide by your natural log of 5, we're going to get that x is going to be 3.043. Yeah, it's good enough. So if you want to double check, just let's see what 5 of 3.043 is. Just to see if we got the right answer. 3.043, and I get approximately 133.95, which can round right up to 134. So remember, there's going to be some rounding errors in our answers because these are all going to be approximate answers for the most part. Occasionally they might be exact, but they're mostly going to be approximate. So here we have 3 to the 2x minus 1, and then we have 7 to the x minus 1. So we're doing the same thing. We're going to do a natural log of both sides. Now remember that natural log pulls the exponent out, so this is just a 2x minus 1 equals natural log of 3. And then we're going to have x plus 1 equals the natural log of 7. All right, so this is going to take quite a bit of work for us. So if we distribute, this is actually 2 natural log of 3x minus natural log of 3. And then this over here is natural log of 7x plus natural log of 7. So we don't want to convert these logs into any kind of number right now because they're just going to be approximations. So we're going to keep everything as long as we can. So we want to put our x's together. So I'm going to subtract the log 7x from both sides. So we have 2 log 3x minus log 7x minus log 3 equals log 7. Then I'm going to add log 3 to the other side, so the terms with the x's are together. And then the terms with no x's are together. So my x's are over here. So the only thing that's different than doing any kind of other linear equations is that we have these natural logs kind of causing us some issues here. So we want to isolate that x. So there's an x here and here. So all I have to do is factor out the x. If I pull out x, then I just have 2 log 3 minus log 7 times the x is equal to log 7 plus log 3. So x, once we divide both sides by 2 log 3 minus log 7, is natural log 7 plus natural log 3 divided by 2 natural log 3 minus natural log 7. So remember to put parentheses around your tops and bottoms when you put this in your calculator, or you're going to get something that's going to be completely wrong. So natural log of 7 minus, plus natural log of 3. Keep that all in parentheses, divided by 2 natural log of 3 minus natural log of 7. And we're going to get x is equal to 12.11, approximately. And once again, if you went back and you checked your answers, Remember, everything's going to be rounded, so you don't expect things to be the same, but as long as they look pretty close. So if I take 3 to the 2 times 12 plus 11 minus 1, so remember that, keep that all in parentheses in your calculator, that is equal to 1.1988 times 10 to the 11th. So just really focus on this part right here. And then we have 7 to the 12.11 plus 1 is going to be 1.2001 times 10 to the 11th. So they're both to 10 to the 11th. So that means it's really going to look like 11988. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And this one's going to be 2001, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's a part of you wants to say they're not very close, but as far as what we're dealing with all these rounding errors, say when you got things like to x to the 10 to the power of 11 or anything like that, just focus on the decimals. And we see decimal wise, those are actually really, really close. Okay. So for you to try out, you got 10 to the x equals 8,000 and 5 to the x minus 1 equals 3 to the x. So notice this has already got a base 10 in here, so you don't necessarily have to use a natural log. There's another log that will be easier to use. So take a moment and we'll come back and work on these. So because this is a base 10 log, I can do log of 10x equals log of 8,000. Actually, I can use log all the time. I don't have to use natural log. But here, because we know that log base b of b to the x is just going to be x, we got log base 10 of 10 to the x. That's just going to say just 10x. X is equal to log of 8,000. And if you use natural log, you probably would still get a correct answer as long as you were careful about rounding errors. So log of 8,000 is going to be 3.4031. And just to check, 3.9031. If I do 10 to the power of 3.9031, make sure I didn't mess it up. Nope. I get 8,000.18 approximately. So we're pretty close. Here we got 5x minus 1 equals 3x. So if I do a natural log of both sides, I can get at those exponents, and now I have x minus 1 times natural log of 5, and here I have x, natural log of 3. So we're going to have natural log 5x minus natural log 5 equals natural log 3 of x. So we want to put the x's together. So I'm going to subtract the natural log 5 of x. So minus log 5 equals natural log 3 of x minus natural log 5 of x. So minus natural log 5 is going to be equal to, because we can pull out the x, to log 3 minus log 5. So we can say that x is just going to be negative log 5 minus natural log 3 minus natural log 5. So this would be your exact answer. Our approximate answer, however, is going to be, so remember, put parentheses around your bottom, negative natural log of 5 minus natural log of 3, 3 minus a natural log of 5. So this is about 3.151. So now we're going to work on solving some logarithms. So we want to express a logarithmic equation in the form of log base b of m equals c. We're going to use the definition of a logarithm to rewrite the equation in exponential form. So log base b of m equals c. It means b to the power of c equals m. Then we're going to solve for the variable and checked our proposed solutions to make sure that the solutions in the original check proposed solutions in the original equation include in the solution set only values for which m is greater than 0. So what we have to watch out for is we get something called extraneous solutions. So sometimes when we solve an equation, the way that we went about doing it causes us to come up with extra solutions that are not truly solutions. So when we look at logarithms, we have to be careful about that because one of the things we know is that this m has to be greater than 0. You cannot do the logs of negative numbers. Right. So we have log base 2 of x minus 4 equals 3. So that means 2 to the power of 3 should be equal to x minus 4. So 2 to the 3 is 8. So 8 equals x minus 4, which means that x is just going to be equal to 4. So we just need to double check. Is log base 2, we're going to have 4 minus 4 equals 3. There's a oh, there you go. I was going to say I made a mistake here. Plus 4, this should be 12. Okay, that makes a little more sense. I accidentally subtracted the 4 instead of adding the 4. So x should actually be 12. I realized that very quickly. Something was wrong there. So we see that log base 2 of 12 minus 4 should equal 3. So a log base 2 of 8 should equal 3. So what power do we have to put on 2 to get 3? Well, that's going to be 8. So we have verified it. This is my correct answer. All right, so if I have 4 natural log of 3x equals 8, just like when we had the exponentials, we had to isolate that b to the n, or b to the m. Here we have to isolate the log. So we need to isolate this natural log. So we're going to divide both sides by 4. So natural log is just 3x equals 2. Okay. So natural log, remember, that is a base e. So that means e to the power of 2 is equal to 3x. So 3x equals e to the squared. So that means x is equal to e squared divided by 3. All right, so e to the power of 2 divided by 3 is approximately 2.463. Well, this is 0, but I'll leave that off. So we just double check to make sure that this works. So we're going to look to see if this I can put in my calculator for natural log of 3 times 2.436. We want to see if that's really, really close to 8. So for natural log of 3 times, so I'm going to put that in there, that is 8 times, 3 times 2.463. It looked like an extra decimal. This is going to be approximately 7.9999691. So yes, we can argue that's 8. So we do have a correct solution. So just as a reminder again, this is your exact solution. This is your approximate. So we have log of x minus 3 equals 1. So we don't have a singular log, but we do know this. We know that log of m times n is equal to log base b of m plus log base b of n. So if we have a summation here, that means we can combine it and go backwards and turn this into a product. So we can rewrite this as log base x times x minus 3. I'm going to use a bracket here to make that easier. This is my m, this is my n. I've just combined them together. And this still equals 1. All right, so we know that this means a base 10. So 10 to the power of 1 is going to be equal to x times x minus 3. So 10 is equal to x squared minus 3x. So what we have here is if I subtract 10 from both sides, we have a quadratic equation. So if I do x, I can factor this into an x minus 5, because remember, once I move everything over here, so this is a quadratic equation, set it equals 0. If I factor this, it factors into x minus 3, x plus 2, because they multiply to give me negative 10, but add to give me negative 3. So either x minus 5 equals 0 or x plus 2 equals 0. So x is either 5 or x is either negative 2. So when you get two solutions, this is definitely when you need to check. So remember, we're only supposed to have, or m is supposed to only be positive. So if you do log of negative 2 plus log of negative 2 minus 3, what you're should be seeing is undefined. Because in both cases, you're going to be doing the log of a negative number, which you cannot do. So that means x equals negative 2 is not a solution. However, if we do log of 5 plus log of 5 minus 3, we should get, just double check that, log of 5 plus log of 5 minus 3 should give you exactly 1. So I put that all in as one group, because if you do it in groups, you're going to get something that's rounded. If you do just this and then you try to stick it in and then just do these parts separately, it's going to cause you some problems. But if I put this all in my calculator at once, this should equal 1. So my only solution is actually x equals 5. So worksheet 2, you have log of 3x plus 1 equals 1. You have 2 log of 3x plus 3 equals 1. You have log base 2 of x plus log base 2. I think it was supposed to be base 2 again. Of x minus 3 equals 2. So let me just fix that in there. That was a little typo on my part. That should be a 2. So log base 2, log base 2. So take a moment on those and come back. So if I do log of 3x plus 1 equals 1, so remember it's a log, so it's a base 10 to the power of 1 equals 3x plus 1. So I got 10 equals 3x plus 1. If I subtract 1, I get 9 is equal to 3x, which means that x is going to be equal to 3. So if you want to, you can double check that. So that is log of 3x times 3 plus 1. If you put that in your calculator, we'll simplify that. It's going to be log of 10. So that should give us 1 back. So we do have a correct answer there. All right. So we're going to do this again, but now we're going to do B. So B is 2, a natural log of 3x plus 3 equals 1. So let's get log by itself. So we're going to subtract 3 from both sides first. So 2 natural log of 3x is going to be equal to negative 2. We're going to divide both sides by 2. And we're going to get natural log of 3x equals negative 1. So we got e to the negative 1 should equal 3x. So that means that x, or 3x, equals e to the negative 1. X is equal to e to the negative 1 divided by 3. So if you do e to the negative 1, and then you divide by 3, you are going to get approximately 0.12263. So I'm just rounding these to somewhere between 3 and 5 places. I didn't specify on here. I'm just sort of picking some numbers. So this is either this or this, depending if you need the exact or approximate solution. And like I said, if you want to, you can always double check it and plug in 0.12263 back into the equation and see if it actually is going to give us about 1. Let me see, what do I get when I do it? Yeah, I get 1.00006. So yeah, it's really, really close. All right, let's do this one more time. So we're going to do C. So C, log base 2 of x equals log base 2 of x minus 3 equals 2. So we are going to combine this to a log base 2 of x times x minus 3 equals 2. So that means 2 to the power of 2 equals x squared minus 3x. So we have 4 equals x squared minus 3x, or x squared minus 3x minus 4 is going to equal 0. So this factors into x minus 3, x plus 1 equals 0, because the product's going to give me negative 4 and the sum is going to give me negative 3. So either x is going to be 4 or x is going to be negative 1. So if we go back and we check, what we'd see if we did a log negative 1 plus log base 2 of negative 1, log base 2 of negative 1 minus 3. We can't do logs and negatives, so that is undefined. So this is going to be my only solution, because that is going to be a log of 4 plus a log of 4 minus 3, which is going to be a log base 2, sorry. A log base 2 of 4, which is just going to be 2, plus a log base 2 of 1, which is just going to be 0. Okay, so sometimes we don't have something that's so easy that we can't necessarily just write it into a exponential and solve it. We want to express the equation of the log of the form log base b of m equals log base b of n, which this form involves a singular logarithm whose coefficient is 1 on each side of the equation. Use the one-to-one property to rewrite the equation without logarithms. So log base b of m equals log base b of n equals m, or sorry, is m equals n. Then we're going to solve the variable. And once again, we're going to check our solutions because sometimes with logarithms, we end up with solutions that do not work. We got to watch out and make sure that everything is defined. So if I have log of x minus 3 is equal to log of 7x minus 3x minus log of x plus 1, remember that we have this property that said log of m divided by n is just log of m minus log of n. So I'm going to take that backwards on this side and then rewrite this as log of x minus 3 is equal to log of x minus 3 minus, or sorry, 7x minus 23 over x plus 1. Now, since we have logs of the same base, we can just set the insides equal to each other. So this is just x minus 3 equals 7x minus 23 equals x plus 1. Okay. So we're going to multiply both sides by the x plus 1. So we get an x minus 3 times x plus 1 is equal to 7x minus 23. So this is x squared minus 3x minus 3. Okay, let me do FOIL. I'm just doing it any way I want to. X times x is x squared. X times 1 is x. Negative 3x times x is minus 3x. And negative 3 times 1 is negative 3. So you can see you're going to end up with a quadratic again. So this is just x squared minus 2x minus 3 equals 7x minus 23. If I minus 7x, that's going to be x squared minus 9x. And if I add 23, that's going to be plus 20 equals 0. So x minus 4 times x minus 5 will equal 0. So that means my solutions are, or possible solutions, is x is 4 or x is 5. So remember, we just have to check those solutions. So if we have natural log of 4 minus 3 equals natural log of 7 times 3 minus 23 minus natural log of 3 plus 1. We're going to stick that in our calculator, both sides, to see what we get. So this is why we need to definitely check our answers. So this side is going to equal 1, but this side is going to, or 0, this side is going to be undefined. Because what we're going to get here is a 21 minus 23. So we're going to end up with a negative 2. So we're going to do a natural log of negative 2, which makes it undefined. So this is not a possible solution. Now if I do natural log of 5 minus 3 equals natural log of 7 times 5 minus 23 minus log of 5 plus 1. What we should be getting now is, let me see. So I'm going to round this, but it's about 0.693. And then on the other side, we're getting the same thing, 0.693. So you should see both sides should look exactly equal. There's several more decimals, but I can't write them all. So in this case, that was because we have 35 minus 23. So this stays positive on this side. So in this case, this is my only solution. So definitely when you get multiple solutions, you definitely want to check them because one of them is most likely not correct. All right, so Try yourself. So log base 3 of 2 plus 2 log base 3 of x equals log base 3 of 7x minus 3. All right, so we have, this is going to be a plus, so we're going to have a log base 3 of 2 times x. Oh, never mind. I just noticed there was a 2 out front. So let me go back. Remember that we also said that a log base m of n is n log base b of m, which means going backwards, this is just log of 3, log base 3 of 2, plus this 2 go back inside. This is log base 3 of x squared equals log base 3 of 7x minus 3. Sorry about that. When I was drawing, I ended up covering up my 2 and didn't see it. Now we can do log base 3 is 2 times x squared equals log base 3 of 7x minus 3. So we have 2x squared equals 7x minus 3, or 2x squared minus 7x plus 3 equals 0. So let me make myself a little more space over here. So we have a logarithm that we need to solve to find our potential answers. So we got a is 2, b is negative 3, and b is negative 7, and c is 3. So if you use quadratic formula, x is equal to negative b, so negative 7, plus or minus b squared, so negative 7 squared, minus 4 times a, which is the 2, and c, which is 3, divided by 2a, which is 2 times 2. So I have 7 plus or minus 49 minus 24 over 4. So this is 7 plus or minus the square root of 25 over 4. So this is equal to 7 plus or minus 5 over 4, meaning I have two different answers. Either I have 7 minus 5 over 4, which is going to be 3 over 4. Oh, sorry, 2 over 4. Or 1/2. Or I'm going to have 7 plus 5 over 4, which is going to be 12 over 4, or 3. We end up with two answers that we have to check. I'm going to make my space here to check them. So we're going to put the check over here. So you may have factored with this one. That's fine as well. I just using quadratic form because I thought it might be just a little quicker. So we need to check. Oops, sorry, it's starting to get a little bit of a glitch here. I'll get through this problem, we'll fix it. Either x is 1/2 or x is 3. So if we do a log base 3 of 2, that's not a problem there, plus 2 log base 3 of 1/2. So we'll do the 1/2 first. That's not a problem. So this is okay because I'm doing a log of a positive. This is okay because I'm doing a log of a positive. The question is going to be here. Log base 3 of 7 times 1/2 minus 3. So this is going to be a 3.5 minus 3, which is going to be a 0.5. So this one should be okay. So you can check like that, or you could also just go back and go, well, this is just log base 2 over, well, natural log. You can do is change a base formula if you wanted to. And you could do a natural log of 2 divided by natural log of 3 plus 2 natural log of 1/2 divided by natural log of 3 each equals natural log of 7 times 1/2 minus 3 divided by natural log of 3. I guess I'm sorry, I'm having a little problem with my pen right now. If you did that, you would find that both sides are equal. So that one's an okay answer. This side would be approximately negative 0.631 equals a negative 0.631. So this one is okay. So now let's check the other one. So if I do a natural log, or sorry, not natural log, a log base 3 of 3 plus 2 natural log, I'm sorry, I put that in the wrong place. Log base 3 of 2 plus 2 log base 3 of 3. So once again, this one's okay because there's a log of a positive. This one's okay because there's a log of a positive. And then we would do a log of 7 times 3 minus 3. That should also be okay, because that is just 21 minus 5, which is going to be 16. So that should be okay as well. So this one also works. Also, if you stuck in your calculator using that change of base, you would get 2.631 on both sides. So this is a first. We actually really do have two solutions here. So my solutions, we'll just do this. These are my solutions. So both of them are the correct solution. Sorry, like I said, I'm having a little glitch right here. So I'm going to fix it and come back. All right, so just some application problems, which we're going to do several more of here in the next section. So how long to the nearest tenth of a year will it take $1,000 to grow to $36,000 at 8% interest compounded annually? So we want to end at 36,000 compounded quarterly, sorry, annually we should compound quarterly. And then we're starting with $1,000. So this is the 1 plus the rate, so the 0.8. We're compounding quarterly, so we divide by 4. And this is going to be 4 to the power of t. So this will be 1. If we combine that together, the the 1 plus 0.8 divided by 4 is just going to be 1.2. And this is the power of 4t. Okay. So we have a exponent here. So we want to isolate the exponent. So we're going to divide by this 1,000, which is going to leave me with 36. And we can get a decimal version of that. So your 36,000 divided by 1,000 is going to be 3.6 is equal to 1.24 to the t. So we can use a natural log of both sides. And that natural log will pull this exponent out front. So this is natural log of 3.6 is equal to 4t natural log of 1.2. So we want to get t by itself now. So if we divide by the log, we're going to get 4t is equal to natural log of 3.6 divided by the natural log of 1.2. Then we divide by the 4, we get t is equal to the natural log of 3.6 times 4, or then divided by 4 times the natural log of 1.2. So this is the exact answer. So we want to round to the nearest year. So we're going to put this all in my calculator all at once. So we have natural log of 3.6 divided by natural log, 4 times natural log. There we go. Of 1.2. Just a minute here. Something is not right. So I apologize. I made an extremely silly mistake. 0.08. I was like, we're making way too much money. Yeah, okay. So this would actually be 0.4. So this is why it's nice to know this stuff, because when I looked at my answer, I realized my answer was really, really off. Like it was not making any sense. All right, so you should get about 8.16. So we're rounding to the nearest year. So we're going to round that to 8 years. It's going to take about 8 years to get there. All right, so work on this one. So the percentage of adult height obtained by a girl who is X years old can be modeled by fx equals 62.35 log x minus 4, where x represents the girl's age from 5 to 15 and fx represents the percentage of her height. At what age has a girl obtained 97% of her adult height? So for this one, you want to make sure that you put in a decimal of 97, so 0.97. Oh, actually, no, let me look back at the numbers. I think you can just use the 97 straight up. They should have 97 equals 63 plus 35 log of x minus 4. So we want to isolate the log. So we're going to take 97 and minus 63. So that is going to be 34 equals 35 log of x minus 4. And then if we divide by the 35, we get 34 divided by 35, which we'll leave like that, log of x minus 4. So this is a base 10, so we know 10 to the power of 3/4 over 35 should equal x minus 4. So x should equal 10 to the power of 34 over 35 plus 4. So 10 to the power of 34 divided by 35. Oops. There we go. Minus plus 4 is going to be about 13. So we don't total to rate this to. So we're going to say 13.36 years old. If you want to, you can always plug that number back in and just see if it actually is going to work. So when I plug it back in, I get second, something's slightly off here. Okay, I just put a number wrong into my calculator, so you get 96.89, so very close to 97. So we have a very close answer here.